Hey guys, can you hear me okay if I speak at this volume? Awesome. Right, so you want to make a game with HTML and JavaScript. Well, I'm going to assume you do, because that's the premise of my talk. I don't have time to tell you about why that's a compelling idea, but hopefully I've already got your interest. So there's a few things we're going to need to do if we want to make a game and have it work in the browser. We're going to have to load assets, right? So pulling in files from Ajax, like it says, and know when everything is done and fire some events so we can get going with the rest of our game. Okay, we're also going to have to draw things. So we're going to have to put a canvas up on the page, and then we're going to have to copy bits from like our images that we preloaded onto the canvas at the appropriate coordinates. But static images are boring, right? So we're also going to have to animate things. Animating means we're going to have to figure out how much time elapsed since the last frame of my animation, and how many frames is this supposed to be playing at. So I've got to make sure that I'm managing a lot of stuff there. What frame should I be on? And I've got to copy that frame's image from the buffer of wherever I had off the canvas and put the right bits in the right spot. Okay, so we got things moving around, maybe, but now we need to figure out how do we move them. So we're going to have to handle input. Input can come from a variety of sources, right? Keyboard, mouse, touch gestures, multi-touch, gamepad support. But I mean, whatever, we can figure that out. We're going to have to check for collisions. Games are typically not very interesting unless something happens when something touches something else. So that means we have to figure out, I've got to, this thing is at this XY coordinate, this thing is at this XY coordinate. I know how big this one is and how big this one is, so I can figure out if they overlap. It's just some math. Luckily, it's not even matrix multiplications like we just saw. It's a little bit simpler than that. So I think we're in good shape there. Games are also not very fun if they don't make noise, so we have to figure out how to play sounds. In the web, that means we're going to have to make web audio contexts and maybe multiple web audio contexts. We got to figure out how we can play multiple sounds at once. But yeah, okay, whatever, we can do that. Then we need to manage states. So, we'll have like our title screen, tap to start, and we'll have our gameplay screen, and then eventually we'll lose and it'll say game over. So those kinds of things. So our game is going to have to know how to transition between these states and what it should be doing when it's in each state. Okay, so that's our plan of attack, right? All of that stuff, and not very much time left. Look, none of this is hard. You can do it, all right? Don't. Make your game. We have frameworks for web development, for making API servers, whatever. This is all about common stuff that we don't want to have to focus on. All of that stuff, that's the common stuff. That's not your game. Don't make that stuff. You can, but then you're never going to release your game. I almost promise you that. So I want to tell you about one game development framework that I've been really excited about for a while. It's got a lot of popularity. I think it's really cool, and that's what I want to share with you today. It's called Phaser. It's open source. It's designed to work great on mobile, which means it also works good on the desktop. And it's for 2D games. So in my hobbyist game developer career, I can't call it a career because it's a hobby, but I said, I want to get good at making 2D games before I worry about 3 dimensions, because that's just a lot more complicated, and I have to learn about meshes and cameras and stuff. And so we're going to stick with 2D, especially for this talk. That's just a screen cap from Phaser's website, highlighting some of the features it has. We'll get into more of it later. So it's built by a company called PhotonStorm. The lead developer, his name is Richard Davey. He was the technical director at Aardman Digital for 6 years. Aardman, Wallace and Gromit, so that's pretty cool. I love his quote here. Okay. So basically, there's a ton of HTML5 game frameworks out there. Which one should you pick? There's a lot of free ones too. Phaser's free. But his point is, if it's just a couple people working on it as a hobby, it's not going to be as good. PhotonStorm makes all of their games with Phaser, so you know that it's up to date. And it's actually quite an active repository online. It's got a lot of stars on GitHub. So if we do those calculations and measure its worth, I'm sure it's really good. So let's cover Hello World in Phaser. What's the bare minimum we need to do? For that, we need to talk about some terms. The first is a sprite. So a sprite is something we put on the screen and move around. If I have time at the end, I'll get into where the term sprite comes from, because I bet a lot of you don't know. And I certainly didn't know until I looked it up. And it's an interesting piece of history, but we'll get there at the end if we have time. So All my examples, by the way, are in CoffeeScript. I hope you'll forgive me if that's unusual for you. I used CoffeeScript because it's terser, and it means I can get more concepts onto the screen quicker. If you don't understand CoffeeScript, I'm here, and I'm going to explain everything anyway, so hopefully it won't be too confusing. So the first thing we do is we make a new phaser game. We tell it how wide and how high we want it to be. And then that third argument, phaser auto, is it's saying, I don't want you to worry about rendering on the canvas or in WebGL. I want you to use whatever the best thing the browser or the phone can handle. You can specifically say, no, I always want you to use the canvas rendering engine, or oh, I want you to use WebGL. WebGL is obviously faster. It's hardware accelerated. Auto will take care of figuring that out. The next one is an empty string, and that's just saying, this is the container I want the game on my HTML page to load into. So if you have a div and maybe you want this game to be part of a web page for some reason, I mean, it's not a really popular use case, but you might have it. So you can target a particular div ID there. If you leave it empty, it's just going to append to the body. And lastly, we give it three, well, you can give more than three, but the three key ones are preload, a create, and an update function. And these are the things that that Phaser's going to kick off at the appropriate times to sort of bootstrap our game. So preload, all we're going to do is load a logo, and so that's at phaser.png. And that's going to happen once, right when the game's ready to go. Create is going to say, right, I'm going to make a sprite from that image asset that I preloaded, and I'm going to put it at the XY positions 200, 200. Update, we're not going to use here because this was just a hello world, so nothing's moving around yet. But if things were moving around, they would probably happen in the update function. So Phaser's going to call preload once to get all your shit loaded, and then it's going to call create to do anything that you need to do once after everything was preloaded, and then it's going to call update on every frame as fast as it can. And it's using request animation frame behind the scenes so that it plays nice in the browser. So we'll get more into the update callback later. That's the basics. Ready to make a game? So as you can maybe tell from that image, I want to do Plants vs. Zombies as a technical demonstration. Disclaimer, it's obviously not the real Plants vs. Zombies from PopCap Games. PopCap, if you're out there on the internet and you're listening, forgive me for using some of your sprites here. I think Plants vs. Zombies is one of the greatest games ever for the iPhone. If you haven't played it, you should. If you haven't played it, what we're building will be a little bit, you won't have the context to know what we're getting to, but you'll see a demo at the end, and then everything we've covered will make sense. So I took some sprites from Plants vs. Zombies because it's more interesting than looking at like squares versus triangles, and I'm not an artist. So another term we have to talk about is a texture atlas, and that sometimes is called like a sprite sheet. So this is a thing that's one big-ass image of all of your little images that you want your game to have. And you, in addition to this one big image, you've got a manifest file that says, right, he's got the plant icon, and that's at this XY position in the big image, and it's this wide and it's this high. And each frame of all of your animations, like the zombie walking or whatever, the plant shooting, those all live as little sub-images inside that big one. So that's a texture atlas. Making one is actually really easy. There's a free tool called Texture Packer, and the basic version is free. You can pay for more features, but I haven't needed them yet. So imagine we have all of those files on our computer. We want to make them into one texture atlas. You drag them in a texture packer, and there's some settings here. I don't think you can read any of that, but there's a setting there that says data format JSON hash at the top. So it'll output in a way that anything that knows how to grok JSON can handle, and that includes Phaser. And what you get back is these two things. You get one big image with all the little ones inside of it, and you get that JSON file that says each frame name, which is the file name from each image, and it's X and Y, where it's located in the big image, and how wide and how high is it. So how do we use that in Phaser? It's actually ridiculously easy. So in our preload, we're going to load a texture atlas. We say using the JSON hash. We'll call it sprites. That name is important. That's what we're going to use to load individual things from that atlas later. And that's where you find the image, and that's where you find the JSON manifest file for it, in my example case anyway. So in create, after we've preloaded, OK, we want to stick grass for the background for your game. That doesn't need to be a sprite, so Phaser can say, so sprites are things that are probably going to move around. They don't have to, but they usually do. An image is going to be something that's probably static. It's a little bit simpler behind the scenes in how it's rendered. And then we're going to make a sprite. So we put the grass on, and then we're going to say at x and x400, y400, from my sprite sheets, use zombie1.png. That's the frame name. So add a sprite using that image. Update, nothing yet. What does that look like? Looks like that. OK, nothing's moving yet because, again, all we did was stick grass and stick a little zombie on the screen. So let's spawn zombies for real. So in Plants vs. Zombies, they start out on the right-hand side, and they sort of walk across to the left-hand side, and they're trying to get to your house so they can eat your brains. So how do we do that? So we're going to use this thing called physics group. This will let Phaser tell me when things are colliding with other things. We don't have to put zombies in a physics group right now, but I know that I'm going to want to know when the bullets from the plants are hitting them. So I'm going to make a physics group for creating all the zombies right away. There's different physics engines built into Phaser. The arcade one is the simplest, and it's probably all you need unless you're doing really fancy stuff. So the arcade one will just tell you, when things are overlapping, and I can give things velocity, and they'll move across the screen at that velocity or that acceleration. If you need more fancy stuff, like you want to say, oh, well, there's friction, and my bullets have mass, and when they hit the other thing, like it knocks him back by how much mass he has. And there's another really popular physics library called P2 that Phaser also has built-in compatibility with, but we're just going to use the arcade one. And we're going to call our physics group zombies, and he's going inside the game world, by the way. That's what that third argument is. So we're going to make a sprite using that physics group right there. We'll say we're going to create him at some x and some y from the sprite sheet called sprites, right, that texture atlas name. And we're going to start him out at frame zombie1.png. Our x and y we'll get from the game world's width. So he'll start out at the far right, and the height will be random. Phaser will give us a random number generator built in. So pick a random height between 0 and the height of the game world. And we'll also give the zombie some health. And that'll come into play later when we make our bullets from the plants hit the zombies. And now we want to animate them, right? So animations are just a little bit of a more complex form of making a sprite from the texture atlas. We say, OK, on this sprite, I want to make an animation. I want to call it walking in this case. And here's the 3 frame names from my texture atlas that comprise that animation. And I'll say, in this example, I wanted to play at 5 frames per second. The next argument after 5, that true, says I want it to loop, right? Because the zombie's not just going to take one step and then stop. He's going to keep taking the same animation loop. False is it's a little bit of a wart, I think, in the Phaser API, but maybe we'll clean it up eventually. It means these frames aren't numbers. They're actually references to names in the texture atlas. It's not like use frame 0, frame 1, frame 2. So you have to say false for that right now. And then we're going to say play walking, right? So that sprite, I gave him that sprite. I taught that sprite, he's got a walking animation, and I can just say, OK, play that walking animation, and Phaser will take care of figuring out how to render all that. We're also going to set the sprite's velocity to -20, so that'll move him by 20 units to the left, right? Because the negative velocity in this world, the origin is the top left, and that's what it looks like. So there's our zombie moving across the screen. OK, let's do more. Let's plant some pea shooters. How am I doing on time, by the way? Is anybody keeping track? 10 more minutes. OK. Yeah, we're doing good. Let's plant the pea shooters. That's what these things are called that shoot peas at the zombies. So that's going to look really similar, right? We're just going to make another physics group, except this one's going to be for the pea shooters, the plants. And now we need to get into some interactivity. So I want to say, right, when I tap on my screen, I want the game to figure out where I've tapped so I can put a plant there. So imagine for a minute that we knew the x, y coordinates we tapped at. What I can do is I'll say, right, I want to make a plant from my plants physics group at that x and y. And I want it to start with the pea shooter idle 1 frame. So how do I get the x and the y from where I've tapped? Just like that. So Phaser, it'll normalize all your pointer events. So if it's from a mouse, if it's from a finger tap, the last one to happen, or in this case, the first one, because we're just going to use one finger to interact with this game, it will be on the active pointer, and that's how we can get that stuff. So we also want to give an animation for idle. We might, in Plants vs. Zombies, if you remember, the plants kind of do a little dance while they're hanging out, and it's really cute. In this case, just for the purpose of time, I'm not going to introduce different animations. We're just going to have our plants constantly, they're static. They're not going to move. But we know how we could make them move because we know how to make zombies walk, and it'd be the same for these plants. So we're making an animation that's just 1 frame long. We're going to tell it to play. And it doesn't need to loop because it's not going to change. Lastly, we want to teach the plants how to shoot, at least from an animation perspective. So when they decide they're going to shoot, we'll have some animation we can trigger that'll make them look like they're, spitting out a little pea. So that's very similar to the other animations that you've seen me set up before. We also want to say when the shoot animation is completed, so sometime later, the plant's going to say, right, I want to shoot my pea at the zombie. When he does that, he's going to do his animation. At the end of that animation, on complete, that's when I want to make a new sprite, which is the little pea that's going to come out of his mouth and is going to get shot at the zombie. So Phaser gives us callback events for when the animations play. That makes it really easy to do that. And that's what this looks like. So there we are. All we're doing is planting, remember. We're not really shooting it. We just set up the animations for it. So we're touching, and plants are showing up where we're touching. So let's get into shooting the zombies. Imagine we had extracted a plant class here, or a class in JavaScript. It'll make things easier. So just like Phaser's main game loop we'll call update, it'll also, when it's updating each tick of your game, it'll call each sprite's update function if it has one. So if you give it one, that's where we can teach each plant, right, do you have a zombie in front of you yet? Because if you do, you should shoot him. That's what we're going to do. So we're going to say this shoot, well, let's go back for a minute. This shoot, if there's a zombie ahead and I can shoot. And the whole can shoot thing is because if we didn't put that in, he'd have no firing, throttling, and he would just shoot every frame. It'd be like, a million P's on the screen. So we'll throttle that down a little bit. So that's what we want to be able to write, something like that. Shoot if there's a zombie and if I'm allowed to shoot. So here we're going to say this is how we do a shoot. When we shoot, we're going to remember what time we just shot at. So that's how can shoot is going to figure out if it can shoot again or not. And we're going to say play the shoot animation, right? And we know at the end of that shoot animation that we can create a P. So here, we're going to say also in this example, we'll just create the P sprite right now. We'll say make a new sprite from the projectiles physics group. So it'd be similarly set up. And at the position X and position Y of the P shooter, right? So of the sprite that is currently thinking that he's going to shoot. And set the P's velocity to 150 of whatever number, some on the x-axis, so some number that makes it look like it's flying fast enough. Let's also tell it, okay, hey P sprite, I want you to, every time the game is ticking, check if you're out of bounds yet. And if you are, kill yourself. Get out of the game's memory. So we don't have to keep track of that stuff, right? If there's no zombie, or if the zombie dies and the plant makes to shoot one more P before the zombie dies and the zombie's gone from a previous P, that P will fly off the screen and it'll get cold by Phaser automatically. So a few quick things again. There's the zombie ahead implementation. We don't really need to worry about this right now. There is the can shoot implementation. And time since last shot is just that. It's a simple calculation. That's what this looks like. So now we're shooting, but oh crap, look, our P's are going straight through the zombies. Well, that's not very helpful. So how do we do collision? We'll get there in a minute. Quick side trip, how do we play sounds? Because when a plant shoots, he wants to go like, pew. I recorded some sounds myself. You'll hear them in the demo in a minute. Audio is really annoying to work with, usually in the browsers, and Phaser makes it really, really easy. So as long as you have an MP3 and an OGG version of the sound effect, you load them all in a very similar way. So I'm going to tell Phaser, right, load an audio asset. Let's call it pshoot, and here's where to get the sound files from. Then I'll make an audio placeholder on game, just an empty object. And in that, I'll put a key called pshoot, which is game add audio pshoot, right? So load audio and add audio. That's sort of the symmetry you're looking at. Load will preload those files, and then add is going to add it into the game. And so we're going to remember it inside that game.audio.pshoot, so we can call play on it, like that. Okay. Obviously, I don't have an animated GIF to show off what the sounds sound like, but I'll get to the demo in 1 minute. So, sorry, I skipped ahead. Let's hit the zombies with the P's. This is a collision. So, inner game update function, we're going to say overlap. So we're setting up a callback, and we're saying, hey, Phaser, tell me whenever any of the projectiles overlap with any of the zombies, I want you to call this handle zombie hit function. So what does that do? First thing is we're going to play a splat sound, so that'll be like the sound of the pea hitting the zombie. Then we'll make the zombie take 1 damage. So remember, he started with 5 health, so he's going to get 1 damage. So after 5 peas have hit him, his health will be 0, and that's a convention that Phaser gives you. If a sprite has health, and you take that health down to 0, Phaser will cull that sprite from your game rule automatically, because that's a common thing that you might want to do. And we'll also kill the pea, right? Otherwise, the pea would keep going if we didn't manually say, right, okay, this pea hit a zombie and he should go away. This is what that looks like. It's just like what you would think. So there they are. They're hitting the zombies, and hopefully he'll get killed in a minute. Yep, cool. Okay, full demo really quickly. How am I doing on time, Peter? Oh, 1 minute. Okay, cool. 1 minute, that's good. Let's do the full demo really quickly if I can. Yeah. All right, hopefully you can hear the sound. Let's see. Zombies are coming. And I think that my browser is a little bit bigger than the projector width, but here we go. I'll plant some plants. Oh, that was in the wrong row. Now you'll notice that the zombies will go right through the plants right now in the demo code I've got, because I decided, this is just a tech demo. It's not the full implementation. Okay, let's shut them up. You get the idea. Let's just wrap up really quickly. There's lots of things I haven't shown you. Camera movement. So if your world is bigger than your stage, and you have like a hero or something or a car or whatever, and you want to drive it around, you want the camera to follow your guy around in the bigger world. Phaser handles that seamlessly. Tile maps. So maybe you're making a platformer game like Mario, or it's a top-down thing like an RPG, and you want this world predefined using an editor. You can make that editor, and Phaser knows how to load all the common tile editor formats for you. There's plugins, there's particles, there's complex physics, which I touched on. If you want to learn more, Phaser.io is the official website. This is so cool, and I want to impress this upon you. There's over 300 playable examples on the Phaser website. So if you want to learn how to do something like, how do I make the camera follow a sprite? Go to the examples, and there'll be a lot about camera movement. And one of them will say following a sprite, and you can click on it, and there'll be a bare bones demo that's just enough code to show you that concept. So you can figure out really easily how to get that into your game. The HTML5 Game Devs forum, that URL is really good. If you have questions or comments or anything, let's chat during lunch, or after lunch will be the discussion track for this talk. Thank you very much.